Welcome to our second of 3 videos on working with measurement numbers. In this video, we're going to look at how to add and subtract our measurement numbers, and then of course, how to round them accurately and report them accurately as well. Okay, so how about adding and subtracting measurement numbers? Well, it's really simple. You add and subtract like you do any other number. Just sometimes you have to round. Now, normally you don't want to round until you're done, right? Because that becomes compounded rounding, and that's really, really bad. You get really, really inaccurate numbers. So if you add these things up, just add them like normal, right? We know how to add decimal numbers, so you just add it. You get 8.87. Okay, no problem there. We line up the decimals like always. We want to obviously keep track of the unit of measure, so when you add them all up, it's still seconds, which we kind of glossed over the fact that you better make sure that they all have the same unit of measure, because you can't add seconds and minutes together without doing some conversion, right? You couldn't take 4.1 seconds and add it to 3.5 minutes and just get 7.6 what, right? Minute seconds, right? It doesn't make sense, right? So first of all, you have to make sure your units are all the same, then you can add them up, and then of course you keep that unit with your answer. And then the last thing you do is you round your answer to agree in precision with the least precise number in the calculation. And even though 1.27, right, was accurate to the hundredths place, these two are only accurate to the tenths place. So we have to round back to the tenths place and say that our answer would be 8.9 seconds. Now, I know that seems kind of silly, like why do we make it less precise? And it really comes back to the idea of we don't want to present our solution with more precision than it actually has, right? If you gave your answer as 8.87 seconds, you're basically saying that your answer is precise, right, to the hundredths place, the hundredths of a second. But it really isn't, because these two measurements were only precise to the tenth of a second. There could have been some extra stuff out here, right? This could have been 1.13, and this could have been 3.53. And when we add those all together, that would have given us an extra 0.6, right, in the hundredths place. So instead of a 7, we would have added a 6 to it, gives us 13. This should have been a 3, and this would have been a 9, and it would have been 8.93. You see what I'm saying? So it's not precise to that measurement. Also, instead of 4.1, this could have been, let's say, 4.08. This could have been 3.49. Then when you add all those together, you're going to get a different answer, and it's not going to be precise. It's not going to have the same number in the end. So that's the problem with keeping the precision out at the most precise number. It gives a false sense of precision, basically. Here's another example, right? Only one decimal place. So the 10th place, blah, blah, blah. Add them all together, you're going to have to round back to the 10th. So accurate to 2, accurate to 3, accurate to 3. Our answer is 2. No decimals at all. A decimal place, so we got to round to the nearest whole. So again, the rules are really easy to apply. Sometimes it's a little tricky to understand why, but if you don't care to understand why, then it's going to be pretty simple. You just, apply the simple rules of always round down to the smallest level of precision. And with that, we finish off our short discussion on the addition and subtraction of measurement numbers. Our third and final video, which unfortunately is a bit longer, we'll pick up from there and discuss the multiplication and division of measurement numbers.